Okay, so today we're going to be talking about the unit circle, and we're going to break it down and actually derive this thing from the ground up. But before we get started with the unit circle in general, I want to introduce you to coterminal, which is something we didn't necessarily cover to the last lesson, but we'll use it a little later in this particular lesson. We'll start with just the definition of coterminal angles. Okay, and coterminal angles are going to be defined as, just give me a second, I'll pause it and put the definition down. Okay, so we see it's two angles with the same initial and terminal sides. So we'll look at one, for example. Let's see, if we have, let's go to right here, which was pi force, or 45 degrees, right? So this is angle 45 degrees. And let's say my second angle, if my initial side is there and I go all the way around, which is one revolution, that's 360, right? And then I go 45 degrees again, the blue angle is the 360 plus 45 more degrees, which would be 405 degrees. So what we would say here is that 45 degrees and 405 degrees are coterminal because their initial and terminal sides are in the same location. So basically, when we're working with an angle that's larger than 360, we'll usually just subtract out a revolution so that we're on the unit circle, because we're going to talk about the unit circle today, and it's beneficial to do so. So let's just practice on some coterminal angles real quick. Okay, so this next page we're just going to work some examples working with coterminal. I gave you particular coterminal angles, 2 of them in degrees, 2 of them in radians, and I ask you to give me the angle that's coterminal to this that's on the unit circle. So if we have 450 degrees, how could we get coterminal? Subtract out 1 revolution, which is what and how many degrees? 360, great. So 450 degrees and 90 degrees have the same initial and terminal sides. Now, if we're working with a degree that's negative 79, what do you think we would do to get back to coterminal? Instead of subtracting 360, great, good job, we're going to add 360. So we would say negative 79 plus 360, which would give us 281 degrees. So negative 79 degrees is in the same location, same initial and terminal sides as 281 degrees. Now our next example, we're going to work with radians. And the only difference is that in degrees, 1 revolution is how many degrees? 360. Well, what about how many radians is 1? 2 pi, right? So in radians, it's 2 pi. So it's the same idea. So if I have 10 pi over 3, and I look on my unit circle, which we're going to practice with that today, it's not on the unit circle. That means I need to subtract out 1 entire revolution, which would be to do what? Subtract 2 pi. Okay, so we minus 2 pi. But now we're working with fractions, so we got to go back to some basic algebra, get a common denominator right here of a 3, and then simplify that. So basically, my 10 pi over 3, I'm going to leave it alone because I'm going to get a common denominator of a 3. So if I put that over 1 just so it's a fraction, how do you get from 1 to 3? Multiply by 3, right? So by 3, multiply by 3, that means this would be 6 pi over 3. To subtract, have a like denominator, so 10 minus 6 is 4 pi over 3, and 4 pi over 3 is on our unit circle, so we're done. This guy is coterminal to 10 pi over 3. And likewise with our negative, instead of adding 2 pi, subtracting 2 pi, we're going to do what? Add 2 pi, just like we did for the negative angle up here. So we're going to say negative 7 pi over 9 plus 2 pi. Now I'm going to pause it, get a common denominator, and simplify my answer. Okay, so if we just took one revolution out, this is in the same, these two are coterminal as well. So that's just a little mini lesson on coterminal. And now we're going to move towards working with our unit circle. Okay, so up to this point, the last lesson we practiced converting from degrees to radians. We talked about that one entire revolution around a circle is going to be, try to draw this as straight as possible, is 360 degrees, as well as one revolution all the way around is 2 pi. Now, if I ask you to label angles in standard position without converting to degrees, we're going to be working on that. So first of all, it wouldn't be very hard to label this as this is 0. This would be 90 degrees, 180 degrees, 360 degrees. That's if I divided it into 4 parts, right? What if I ask you to divide our circle into 8 parts? So 1, 2, 3, 4, and these are approximations. It's a rough sketch, so mine aren't exact parts, but we'll get the picture. Okay, so 8 sections, 8 equal parts. Okay, to find the degrees, what would I need to do? 360 divide by 8, and you would find out that each part is going to be how many degrees? 45 degrees, right? So I could say 360 divided by 8 parts, they're equal to 45 degrees each. So then I could label this one 45. I can label this, the next one is add 45, add 45, add 45, add 45, so on and so forth. So that we would have our angles 45 degrees, 90, then this was 135, 180, 225, and then we would have over here, what, 315? Okay, so we can figure out degrees, and we're not going to spend a whole lot of time on degrees because that's fairly straightforward. The part that we're going to really talk about is how do we do the radians? Okay, how do we determine the radians if I don't have degrees? Now, I could always rely on my conversion tool to go from degrees to radians and simply figure out all the degrees and then turn them into radians, right? That's always a fallback. But our particular skill that we're trying to learn now is if I have 8 equal parts, I want to know what the radians are going to be in each one. So if I have 360 of them, or now we're going to talk about radians, which is 2 pi. If I want 2 pi into 8 equal parts, what do I need to do? Divide by 8, right? Which means each part is going to be exactly pi fourths. So watch this. If I start here and I go up one, that's 1 pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths. I'm going to finish it out. Now let's go back and simplify any of the ones that can be simplified, which is going to be this one. I'm going to pause it and do that. Okay, so check these. So we would then go back and simplify it. Okay, my next question to you is, what if I want to divide this thing into 12 equal parts? We change this and I say 12 equal parts. Okay, I'm going to go back in a different color and do tick marks for that. Okay, before we see the 12 equal parts, we're going to back up. This is just a PowerPoint that you're going to be able to look at to see this as we go. About how to work these. Let me start this. So let's see if this works. So I have 8 equal pieces. And remember we said we could go through, their degrees are easy. That's not anything that's going to be hard for you. But if I said let's divide it into 8 equal parts like we just did, each part is pi over 4. So I add pi over 4 each time. I went ahead and reduced on this as I went I usually would go back and do it after like we did in the lesson, but anyway, so 3 pi fourths, 4 pi fourths, 5 pi fourths, 6 pi fourths, that's reduced, 7 pi fourths, 8 pi fourths, which is 2 pi, reduced. Okay, now this is where we were going to start with the next one and say let's divide this thing into 12 equal parts, which I tried to highlight is that's the red sections only. So if you ignored the black and was only able to focus in on the red, it's 12 parts. Okay, I go ahead and add my degrees in that were missing, the pieces that weren't included, and I'll say, okay, let's work on the radians part because that's what we're have the most trouble with. And I'll say if I take 1 revolution, which is 2 pi, it's hard to see over there, and I was like 12 equal parts, guys, the red parts only, then it would simplify to pi 6, meaning each of the red sections are pi 6, and we would just count our way through. 1 pi 6 for this, it looks like orange. 2 pi 6 is reduced. 3 pi 6 was here, it was reduced because it's red. 4 pi 6 reduced, each of the red ones. 5 pi 6, 6 pi over 6, which is just pi. 7 pi over 6, 8 pi over 6 reduced. 9 pi over 6, 10 pi over 6, 11 pi over 6, and this last one would be 12 pi over 6, which once again is 2 pi. By doing that, we have now collectively filled in our entire unit circle. The degrees, pretty intuitive. The radians, not so much, but it's not too bad if you tackle it with 8 parts, do that in one color with a highlighter, and then do 12 parts with a different color, and just do this until you get all the way around. Now, I reduced as I went this time. If you get confused and like counting around, reduce last, and then that's just going to be the way we're going to deal with filling in those parts of the unit circle.